Right now, in the world of AI, there is a massive showdown brewing. We're talking about a fight for the actual silicon, the very chips that are going to power our intelligent future. And the prize? Well, it's absolutely huge.
How huge? We're talking $92 billion. That's the projection for the AI chip market just in 2025. And look, this isn't just about making computers faster. This is about who gets to build the fundamental engine for the entire next technological revolution.
You know, for the longest time, the story here was actually pretty simple. Think of it like the AI gold rush. You've got all these companies rushing to find gold, and just one company was selling pretty much all the picks and shovels. And that company? Of course, it's NVIDIA. Their powerful GPUs, they just became the standard, the undisputed, undefeated champion of AI compute. Period. But that's all changing. See, that absolute dominance is now being seriously challenged. Two of the biggest tech giants on the planet, Google and Amazon, well, they're tired of buying someone else's tools. They've decided it's time to forge their own. And that is the showdown we're going to break down right now.
Okay, so let's meet our three contenders, because each one has a totally different strategy, a different game plan. You've got NVIDIA, the reigning champ, right? And then you've got the challengers, Google and Amazon. And trust me, they are playing a completely different sport.
So let's get right to the core of it. What's the fundamental difference here? Well, look at NVIDIA up top. Their whole philosophy is versatility. Their GPUs, think of them like a super powerful Swiss Army knife. They can do AI, graphics, scientific computing, you name it. And their secret weapon? It's that software, CUDA. It's the industry standard, everyone knows it, it's easy to use. Okay, now look at Google and AWS. They're not playing that game. Their philosophy is all about specialization. They built custom chips, we're going to talk more about these ASICs later, that are designed to do one thing and one thing only, run AI models with insane efficiency. The catch? Well, you got to use their specific software, like Google's JAX or the AWS Neuron SDK, which isn't as simple.
All right, first things first, the question on everyone's mind. Who's faster? Simple as that. If you put these things on a drag strip, who wins in a test of pure raw performance?
And the results are, well, they're pretty clear-cut. Just look at this. We're testing a big language model here. That bar on the right, that's a cluster of 8 NVIDIA H100s. It's spitting out over 4,000 tokens a second. Now look at Google's TPU cluster, just over 2,000. So yeah, NVIDIA is nearly twice as fast. It's not even close. A massive lead for the champ. So if we're just talking about pure, unadulterated speed, NVIDIA is the undisputed king. End of story. But, and this is a big but, that's where this whole thing gets way more interesting. See, because when you're running a business, the race isn't just about having the fastest car. It's about efficiency. It's about the bottom line. The real fight is all about cost. Which really makes you wonder, right? If you're running an app for millions or even billions of users, is having the absolute fastest chip really the only thing that matters? Or is there something more important? To really get this, you have to understand the two big phases of AI. First, on the left, you've got training. This is like designing and building a massive jet engine. It's a huge, expensive, one-time thing. But then, on the right, you have inference. This is actually flying the plane. It's the cost of running that engine every single time a user asks a question or makes an image. And that ongoing, constant cost, that is what businesses really care about. Over time, it totally dwarfs that initial cost to build the model. And this is where the entire story flips on its head. Because when we stop talking about speed and start talking about the cost to actually run these models, look what happens. To generate 1 million tokens on Google's TPU, it costs 30 cents. On AWS, about 40 cents. And on the Speed King, the NVIDIA H100, a full $1. This is incredible. The challengers aren't just a bit cheaper. They are dramatically more cost-effective for the thing that matters most. So how is this even possible? What's their secret? It all comes down to their design. These chips from Google and AWS are what we call ASICs, application-specific integrated circuits. Here's the best way to think about it. NVIDIA's GPU is like a Ferrari. It's insanely powerful, it's versatile, you can drive it on the street or the track. But an ASIC, that's a Formula One car. It is built for one job and one job only, to dominate a racetrack with the most brutal efficiency imaginable. It's useless on a public road, but on that track, for its one specific job, nothing can touch it on performance per watt or cost. Okay, so this begs the question, right? If the challengers are so much cheaper, why isn't everyone just switching over? Well, that's where we get to the catch, the developer's dilemma. There's a powerful hidden cost to leaving the champ's corner.
This quote from some internal Amazon docs says it all. They're seeing low adoption due to the effort required to migrate off CUDA. CUDA is NVIDIA's software platform. And you have to understand, it's more than just software. It's a moat. It's the language that an entire generation of AI developers grew up speaking. Everyone knows it, all the tools work with it, it's the default. So when they say effort, what do they actually mean? It's not like just swapping out a part. It's a huge engineering project. First, you have to completely refactor your code to speak a new language. Then, you have to do this whole compilation step, which is complex and, by the way, not even something you worry about in NVIDIA's world. And after all that, your engineers still have to spend countless hours just tuning the model to make sure it runs efficiently on the new chip. It's a massive headache. So this is the crux of it. This is the trade-off every company is facing. Do you stick with NVIDIA, the easy path, the devil you know, even though it's more expensive to run in the long term? Or do you invest all that engineering pain up front to switch to the challengers and unlock those massive long-term cost savings? That's the multi-billion-dollar question in AI right now.
And believe me, this race is not slowing down for anyone to make up their mind. It is a flat-out sprint, with every company pushing the absolute limits to define what's next.
I mean, just look at this roadmap. It's insane. This isn't a once every few years upgrade cycle. This is yearly. NVIDIA's launching Blackwell, then Blackwell Ultra. Google's got Trillium, then Ironwood. And NVIDIA's already talking about their next platform, Rubin, for 2026 and 2027. The pace here is just relentless.
Okay, so let's boil it all down. What are the key things to remember? 1. NVIDIA is the king of pure performance, but you pay a premium for it. 2. Google and AWS are the champs of cost efficiency, purpose-built for running models at huge scale. 3. This means the real battleground has shifted. It's not about training speed anymore. It's about inference costs per token. And finally, 4. The choice for developers is a tough one. It's NVIDIA's mature, easy-to-use CUDA ecosystem versus the incredible cost savings of these new specialized chips. And all of this leaves us with one final, massive question. What will the future of AI be built on? Will it be a single, universal platform, a one-size-fits-all solution? Or will it be a whole new ecosystem of a dozen different specialized chips, each perfect for its own little job? The answer is still being written. But you gotta understand, the winner here, they don't just win a market, they get to define the very architecture of intelligence itself.